Hey people, get ready to crush everyday TOEFL iBT tests for all modules and make your dreams come true. I'm your motivator and I'll be guiding you through the test prep videos. So don't forget to like, share, and subscribe or you'll be missing out on some serious preparation.
Conversation 1. You will hear a conversation. A female international student visits the International Student Office to ask whether dropping a course will affect her F1 visa status. She also briefly inquires about future OPT plans. First, you have some time to look at the 5 questions. Now listen carefully and answer the questions. Hi, excuse me. I was hoping to speak with someone about my student visa status. I'm not sure if I need an appointment.
No, walk-ins are welcome during office hours. I'm Marcus. What can I help you with?
I'm on an F1 visa, and I'm thinking about dropping one of my courses this semester. I wanted to make sure that won't cause any problems with my status.
That's a really smart question to ask before making any changes. Can I pull up your record? What's your student ID?
It's 77421189.
Okay, I see you're currently enrolled in 15 credits. F1 students are required to maintain full-time enrollment, which means at least 12 credits for undergraduates. So dropping one 3-credit course would bring you to exactly 12, that's still within the requirement.
Oh, that's a relief. I was really worried. So there's no issue at all?
Well, not immediately. But I want to flag something. You have a notation here that you already used to reduced course load authorization last fall. If you were to drop below 12 at any point this term, that would be considered a status violation.
I hadn't thought about that. I definitely won't go below 12. The course I want to drop is worth 3 credits, so I'd still have exactly 12.
Right, so you'd be fine. Just be careful not to withdraw from anything else. And make sure you complete the drop before the deadline, this Friday at 5 p.m.
Friday, okay, I'll take care of it today. Is there anything I need to do on your end, like notify this office?
You don't have to notify us directly. The registrar's system is linked to ours, so we'll see the enrollment change automatically. But if anything unexpected comes up, a hold, an error, don't hesitate to come back.
Got it. Actually, one more thing, I'm planning to do an internship this summer. Should I come back to talk about OPT?
Absolutely. You'll want to apply for OPT through this office at least 90 days before your program end date. We hold information sessions every other Thursday, the next one is next week. I'd strongly recommend attending.
That's really helpful. I'll put it on my calendar. Thank you so much, Marcus.
Of course. Good luck with the rest of your semester.
That is the end of the conversation 1. You now have some time to answer the questions. Conversation 2. You will hear a conversation. A male student visits his professor's office hours to request a deadline extension on a research paper after losing work due to a laptop hard drive failure. First, you have some time to look at the 5 questions. Now listen carefully and answer the questions.
Dr. Hoffman, do you have a few minutes? I know I don't have a scheduled appointment.
Sure, Daniel, come in. I have about 15 minutes before my next meeting. What's on your mind?
I wanted to talk to you about the research paper that's due Thursday. I'm in a difficult situation and was hoping you might consider giving me a short extension.
An extension? Tell me what's going on.
My laptop stopped working on Sunday night. The hard drive crashed, and I lost about 6 pages of work that I hadn't backed up. I've been trying to recover the files, but the technician at the IT center said it could take until Wednesday.
Oh, that's quite unfortunate. Did you file a report with the IT center so there's a record of the issue?
Yes, I did. I have the ticket number and everything. I can forward you the email confirmation if that would help.
That would actually be very helpful. Please do send that along. Now, I want to be fair to you, but I also have to be consistent with the rest of the class. My policy, which is outlined in the syllabus, is that late papers lose 10% per day.
I completely understand, and I'm not asking for a long extension, just 48 hours. I think I can reconstruct most of what I lost and finish by Saturday morning.
Okay. Given that you have documentation and you came to me proactively rather than just submitting late, I'm willing to grant you until Saturday at noon. But I want to be transparent. If the paper comes in afternoon on Saturday, the late penalty will apply to any remaining time beyond that.
That's more than fair. I really appreciate it, Dr. Hoffman.
I also want to suggest that going forward you use a cloud backup service, Google Drive or the university's OneDrive. The IT department provides free storage to all enrolled students.
Yeah, I've definitely learned my lesson. I'll set that up as soon as I get my laptop back.
Good. And Daniel, make sure the paper reflects your best work. Even with this setback, the quality standards remain the same.
Of course. I'll make sure of it. Thank you again, Dr. Hoffman.
That is the end of the conversation too. You now have some time to answer the questions. Lecture 1. You will hear part of a lecture about psychology. Memory consolidation. First, you have some time to look at the 6 questions. Now listen carefully and answer the questions.
Good morning, everyone. Today we're going to talk about a process that happens in your brain every single night, memory consolidation. Memory consolidation refers to the process by which newly acquired information is stabilized and transferred from short-term, or working, memory into long-term memory storage. Without this process, experiences and facts we encounter throughout the day would simply fade away within hours. Now, researchers generally distinguish between two broad phases of consolidation. The first is synaptic consolidation, which occurs at the level of individual nerve synapses and takes place within the first few hours after learning. During this phase, proteins are synthesized that physically strengthen the synaptic connections between neurons, a phenomenon closely tied to what we call long-term potentiation, or LTP. The second phase is called systems consolidation, and this one operates on a much longer timescale, sometimes years. During systems consolidation, memories that were initially dependent on the hippocampus gradually become distributed across the neocortex, making them more resistant to damage or interference. Sleep plays an extraordinarily critical role in both phases. During slow-wave sleep, the deep, dreamless stages, the hippocampus essentially replays recent experiences and transmits them to the neocortex for long-term storage. During REM sleep, on the other hand, the brain appears to integrate new information with existing knowledge schemas, which helps with the kind of creative, associative thinking we need for problem solving. So when you pull an all-nighter before an exam, you're not just tired, you're actually disrupting the very biological process that would have solidified what you studied.
Student, Professor Hartwell, does that mean it's actually better to study, sleep, and then review material the next day rather than cramming everything in one session right before an exam?
That's exactly right, and this is actually one of the most practically important findings in cognitive psychology. The strategy you're describing is called spaced practice or distributed practice, and it's enormously more effective than massed practice, what most students call cramming. Each time you revisit material after a sleep period, you're not only reactivating the memory trace but also triggering another round of reconsolidation, which further strengthens and updates the memory. Research by psychologists like Hermann Ebbinghaus on the forgetting curve shows us just how steep memory decay is without review, but spacing those reviews out, especially across sleep cycles, dramatically flattens that curve. There's one more concept I want to introduce before we wrap up today, and that's reconsolidation. For a long time, scientists believed that once a memory was consolidated, it was essentially fixed, a stable record. But research in the late 1990s and early 2000s, particularly by Karim Nader and his colleagues, demonstrated that when a long-term memory is recalled or reactivated, it temporarily becomes labile, that is, unstable and vulnerable to modification, before being restored. This process of reconsolidation has profound implications, not just for how we understand memory, but also for therapeutic approaches to conditions like PTSD, where traumatic memories might be targeted and weakened during their reconsolidated state.
That is the end of the lecture 1. You now have some time to answer the questions. Lecture 2. You will hear part of a lecture about anthropology. Tool use in primates. First, you have some time to look at the 6 questions. Now listen carefully and answer the questions.
So, let's pick up where we left off on primate behavior and move into one of the most fascinating areas in anthropology, tool use among non-human primates. For a long time, tool use was considered a defining characteristic of Homo sapiens. The famous anthropologist Louis Leakey even once said that we must either redefine man, redefine tool, or accept chimpanzees as humans, and he said this after Jane Goodall's landmark observations in the 1960s at Gom Stream in Tanzania, where she documented wild chimpanzees stripping leaves off twigs to extract termites from mounds. That single observation fundamentally changed our understanding of what it means to be human. What makes Goodall's finding particularly significant is not just that the chimpanzees were using objects that alone might be written off as accidental. What she observed was that the chimps were modifying objects to make them more effective. Stripping the leaves off a twig is a deliberate act of preparation, and that preparation implies a degree of foresight, an anticipation of a future need. This is categorically different from, say, a sea otter cracking a shellfish open with a rock it happens to find. The otter selects a pre-existing object, the chimpanzee manufactures a tool. And that distinction, between tool selection and tool manufacture, is one that anthropologists consider crucial. Since Goodall's initial findings, research has expanded enormously. We now have well-documented evidence of tool use across multiple primate species. Capuchin monkeys in Brazil, for instance, use large quartzite stones to crack open nuts on flat stone anvils, and this behavior has been observed to be culturally transmitted, meaning younger capuchins learn it by watching older, more experienced individuals. What's more, archaeologists have found capuchin nut-cracking sites in Brazil's Serra de Capivara National Park dating back at least 3,000 years, which is astonishing. That means this tool use tradition has been maintained in capuchin populations for 3 millennia.
Student, Professor Okafor, when you say the behavior is culturally transmitted, does that mean primates actually have culture in the same way humans do?
That's a question that sparks a lot of debate, and I love that you asked it. The short answer is, it depends on how you define culture. If we use a minimal definition, socially learned, group-specific behaviors that vary between populations, then yes, many primates exhibit culture. Researchers like Andrew Whiten and colleagues published a landmark study in 1999 in the journal Nature, cataloging 39 behaviors across 7 long-term chimpanzee study sites that appeared to be culturally variable, present in some groups, absent in others, with no obvious ecological explanation for the difference. So within that framework, chimpanzees absolutely have culture. But if we define culture as requiring language, symbolic representation, or cumulative technological advancement, what some researchers call cumulative culture, then we're dealing with something qualitatively different from what we see in other primates. Human technology builds on itself across generations in ways that no other species has demonstrated. So, the honest answer is, primate culture and human culture share important features, but they're not identical. I also want to briefly mention orangutans and gorillas. Orangutans in Sumatra have been observed using tools to extract seeds from fruit and to fashion leaf gloves when handling spiny vegetation. Interestingly, tool use in orangutans shows significant geographic variation. Populations on Sumatra use tools far more frequently than those on Borneo, likely due to differences in social learning opportunities, since Sumatran orangutans tend to be more social. Gorillas, by contrast, have historically been considered less proficient tool users, but more recent field observations have documented gorillas using sticks to test water depth before wading, which suggests the capacity for tool use may be more widespread across great apes than previously assumed.
That is the end of the lecture too. You now have some time to answer the questions. Lecture 3. You will hear part of a lecture about physics. Wave-particle duality. First, you have some time to look at the 6 questions. Now listen carefully and answer the questions.
Alright, today we're entering the realm of quantum mechanics, and I want to focus on one of its most counterintuitive and philosophically provocative concepts, wave-particle duality. At its core, wave-particle duality refers to the experimental observation that quantum objects, electrons, photons, even whole atoms, exhibit properties of both waves and particles depending on how they are observed. Now, this isn't a metaphor or an approximation. This is one of the most rigorously tested phenomena in all of physics, and it has been confirmed in thousands of experiments to extraordinary precision. Let's start with light, because the history of wave-particle duality is really the history of our evolving understanding of light. In the 17th century, Isaac Newton argued that light was composed of corpuscles, tiny particles. At roughly the same time, the Dutch physicist Christiaan Huygens proposed a competing wave theory of light. For more than a century, the debate seesawed back and forth, until Thomas Young's famous double-slit experiment in 1801 seemed to settle the matter decisively in favor of waves. Young showed that when light passes through 2 narrow slits in a barrier, it produces an interference pattern on a screen behind the barrier, alternating bands of light and dark, which is exactly what you'd expect from 2 overlapping wave fronts, and completely impossible to explain with a particle model. But then, just over a century later, in 1905, Albert Einstein published his paper on the photoelectric effect, for which he eventually received the Nobel Prize. Einstein showed that when light strikes a metallic surface, it ejects electrons, and crucially, the energy of the ejected electrons depends not on the intensity of the light, but on its frequency. This is exactly what you'd expect if light came in discrete packets, what we now call photons, rather than as a continuous wave. A wave model simply cannot account for this. So by the early 20th century, physics was in the uncomfortable position of having airtight experimental evidence that light was both a wave and a particle, depending on what kind of experiment you designed to test it.
Student, Professor Szymanski, does wave-particle duality apply only to light, or does it apply to matter as well, like electrons?
Excellent question, and the answer is, it absolutely applies to matter. This was the revolutionary insight of Louis de Broglie in 1924. De Broglie proposed, in his doctoral thesis, that just as light, traditionally thought of as a wave, had been shown to have particle properties, perhaps particles of matter, like electrons, also have wave properties. He derived a formula relating a particle's wavelength to its momentum, lambda equals h divided by p, where h is Planck's constant and p is the particle's momentum. This was an audacious hypothesis, but it was experimentally confirmed just 3 years later by Davison and Germer, who showed that a beam of electrons directed at a crystal produced a diffraction pattern, a signature of wave behavior, identical in character to what you see with X-rays. And more remarkably, when the double-slit experiment is performed with individual electrons fired one at a time, the interference pattern still builds up over time, even though each electron goes through the slits individually. That result is extraordinarily strange and has never been fully resolved within classical intuition. The framework that physicists develop to make sense of all this is quantum mechanics, and central to it is the concept of the wave function, described mathematically by Schrödinger's equation. The wave function encodes the probability of finding a particle in any given state or location. Before a measurement is made, a quantum particle doesn't have a definite position, it exists in a superposition of many possible states simultaneously. When a measurement is made, the wave function is said to collapse to a definite value. This is the measurement problem, and it remains one of the deepest unresolved conceptual questions in physics. Different interpretations of quantum mechanics, the Copenhagen interpretation, the many worlds interpretation, pilot wave theory, offer radically different accounts of what's really happening, but all of them reproduce the same experimental predictions. And that, in a way, is what makes quantum mechanics both so powerful and so philosophically unsettling.
That is the end of the lecture 3. You now have some time to answer the questions. That is the end of the TOEFL iBT listening test. You now have some time to review your answers.
Hey people, how was your test? Don't forget to like, share, and subscribe, or you'll be missing out on some serious fun. See you tomorrow!